we're going to look at the operation of the vibrators. Okay. Now we're going to start off by getting the necessary control elements from the power circuit. Okay. So first off, we're going to get the residue current associated auxiliary contacts. So we're going to create one group which is normally open, okay, then another group which is normally closed, just in case we need those. Then we're just going to say we're going to just save. Okay, so this is one set, and then we're going to go to the magnetic tripping device. Okay, we're going to go to this here device. Of course, we're going to change the symbolic name to 4AE31. Okay, so first off, item identifier, this is going to be 4AE3, 4AE31, 4AE3, 4AE3-1. Okay, and then we're going to create contact groups which are both normally open, and then the other group is going to be normally closed. And then we move on to the thermal overload. Okay, this is going to be one group which is normally open, okay, then another group which is normally closed. This is for vibrator motor 1. Okay, this is for vibrator 1. Then we do the same thing for vibrator 2. Okay, this is going to be 4AE41. Okay, so this is going to be 4AE4, 4AE 4AE4, 4AE4-1, and then we need to create associated normally open and normally closed auxiliary contacts. So basically two separate groups. Okay, so we're going to apply this, and then we're going to create for the thermal overload. We're going to create two contact groups. Okay, so one group is normally open, the other group is normally closed. Then just save, and thereafter we can just close this. So the only thing we need to do now is we're going to get all of these control interlocks that we've created, or control conditions if you want. We're going to pour them into this document. These are the associated auxiliary contacts that we've put into the vibrator control document, because we know we're going to be needing these. So we're just going to deal with vibrator 1 at first. Okay, so and I bet we're going to need the no, I mean, this document is already open, but we need the lubrication, because we need to borrow the multi-position selector switch, so we can essentially copy this section here. Okay, we can copy this into this document. So we've got the multi-position selector switch, and then I know for a fact that local station. We'll be needing a control relay. We'll be needing a bunch of control relays, and then we could also be looking at some indicator lamps. So as opposed to using the library, we just copy them from documents that we've already created. Okay. So this is how this drawing is supposed to look. So for AE2, we already have this. Okay, so how do we pull this off for 4AE2? So can this be modified, I wonder? So 4AE2, let's look at the builder. So the one which is normally opened. Can we go for a double throw? Okay, so if we go for a double throw and then just apply this, okay, that's 4AE2. So like before, our starting point will be this position for 4AE2, which we have said is like a double throw condition. Okay, so we'll put it right there. Okay, transformation, rotate right, then transformation, flip vertical. So we can get it like so. So this is our 4AE2, right? So this is 4AE2. So in this case, on the one end, we're going to get like a link. Okay, we want to get a link. We're going to get a link. We're going to come under electrotechnical NEMA. Okay, we're going to come to links and connections, then link, or rather lines and connections, under terminals, then links. What we're looking for is an input link. Okay, so transformation, rotate left, and this is going to be linked to N5, right? This is N5. So first off, we're going to link it to L5, and then thereafter we'll call this as L5. Okay, we'll call this as L5. Then we're going to copy this. It's going to be associated with N5. Okay, and then we're going to call this as N5, like so. So this is the neutral end of the control voltage. We're here, right? So the control voltage for us is like 120 volts. So we connect it to one end of 4AE2, and thereafter we need 4AE3. So 4AE3 normally closed. So okay, so 4AE3, 4AE4. Let me just do this. Transformation, rotate left. So this is 4AE3, and then we're looking at 4AE4. transformation, rotate left. So this is 484. Then do we have 481? Okay. 481 is most likely a control relay. Okay. So 481, we need to create a control relay as designated as 481, right? So come to any control relay, CR, okay? Get rid of this, won't be needing this. Of course, this now becomes 481, right? And then of course we need to have a contact group which is like normally closed, okay? Which is normally closed to be in this position, okay? Transformation, rotate left. We're there. Okay, so this is 481, and then after 481 we have the multi-position selector switch. Okay, so we have this selector switch. Okay, so we have 482, 482, 483, 484, then 481, the multi-position selector switch, and then we've got motor 1 and motor 2 isolators, remote start, remote stop, local stop, and then we've got 282. Okay, so right after that we need the isolator auxiliary contact. Okay, that one we'll get from the power circuit. Okay, so we get that from the power circuit. So view power circuit like so. Then what we need from here is the isolator for this vibrator. For vibrator 1 we need the auxiliary contact of CB4. Okay, so builder, we need a contact group 1 which is normally open. Okay, so that's our isolator. So we need to get this into this document. Okay, so that's motor 1 isolator, motor 2 isolator, but in our case we're just going to have just one isolator. Okay, so we're just going to have this. Transformation, rotate left. This is our CB4. Okay, then it's going to be okay. Let's move this a little bit. Oh, okay, it comes after the isolator, so it's going to be like right here. Okay, so this becomes the isolator. So we need remote stop and then the local stop. So we come under switches. Okay, we come under control, then switches. Okay, then push button switch. Okay, I know for a fact that we're going to need the start and then we're going to need the stop. Okay, so one of these is the remote stop, then the local stop. So transformation, rotate left. So this might as well be this might as well be the local stop. Okay. So this can be the local stop, and then if we create a copy of this, okay, another switch of this can be the remote stop. Okay, it can be the remote stop, like so. So we have the remote stop, the local stop, and the vibrator control interlock, which is like 282, right? So 282, do we have that particular? No, I don't believe we have that, but the vibrator control interlock was in the crusher main drive. Okay, that's where 282 was. So this is 282. We need to create an associative normally open contact. Okay, like so. Save, close, and then we need to move this contact into our document. Okay, so transformation, rotate left, okay, so that's 282, the vibrator control interlock, which comes after the local stop. Okay, then thereafter we've got the remote start, local start, and the ceiling contact for 4AC1. So we need this. Okay, transformation, rotate left, so we have things like this, and then data, this is going to be the local start. Okay, then this other one is going to be the remote start. Like so. Transformation, rotate left, transformation, rotate left. Okay, so we have reached this point, and then 4AC1, I think we have 4AC1 as a coil. Okay, so this is 4AC1. So 4AC1 comes here, transformation, rotate left, and then we need an auxiliary contact of this. So we need a normally open contact. So we create an associated normally open contact. Okay, which now transformation, rotate left, is going to function as a ceiling contact. Okay, it's going to function as a ceiling contact. So maybe this one, this contact, and this one we're going to distribute horizontally. Okay, so now we have this whole arrangement. Okay, so the only thing that's remaining to be done is linking them together, but I feel we don't really need to leave a lot of space. Okay, Okay, so this is the opposite end, the neutral end. Okay, so N5 is like the neutral end, so we connect it to A1. Okay, like so. Then all we have to do is, maybe this is okay, we can just work with it like this. So we just need to, okay, let's see. So we can just link them together now. Okay, so we have this whole part. Then we've got the remote start, the remote stop, local stop. Then we have this multi-position selector switch, and then of course we have what is passing for a paddle switch. Now we do not have a paddle switch. Okay, so the only thing we can do is we need to simulate a paddle switch, and like before, we'll make use of an emergency push button. So protection, or rather, is it under switches? With brake contact. So we're going to make use of this emergency push button, transformation, rotate left. Now this is just a placeholder for a paddle switch. Okay, because we really don't have a paddle switch, but we need to simulate the operation of a paddle switch. Transformation, rotate left. So this is a paddle switch for simulation of the paddle switch. Okay, and then this is just going to be across the control voltage. Okay, going to put it across there. Then we're going to insert a control relay. Okay, going to insert a control relay. This control relay in as much as this is like okay, so how best can we do this? How best can we do this? Okay, basically we can simplify. Okay, let's see. Okay, so let's see. Okay, so okay, so if we said this was our paddle switch, okay, transformation, Oh, come on. Transformation, flip vertically. So if this was like our powder switch, the simulation for the powder switch, okay? So what it would be is that we can get rid of this part, okay? We can get rid of this part to simulate the powder switch. We won't be needing this one. We won't be needing this, but we need this push button configuration. So this right here is the one that we're going to call powder switch. Okay, we're going to call this as a powder switch. Okay, and then it's in this path of the control. So after the multi-position selector switch, we need to have the powder switch right before the isolator. Okay, so maybe this we can push down a bit. Okay, and then when that is done, we can insert the it's going to create some complications, so maybe we can do it like this. Okay, then we can move it a little bit to the right just for alignment. So this is our powder switch. This is just to help us simulate the operation of the powder switch, which we don't have. So this is the powder switch bin level, okay? And then on this other end, it's going to be linked to an indicator lamp, okay? So we need this lamp now to be in this position, okay? 4DH2 will be the powder switch operated indication. So so this is going to be the powder switch. It's going to be the powder switch operated. Okay. So transformation, rotate left, like so. And then we're saying it's going to take off from this point. Okay. Okay, that's what we're going to get. Then thereafter it's linked to the other end of to the neutral end of the control. Okay, so it's pretty much going to be like this. Okay, and then of course this position is going to be vibrator 1 selected. Okay, so we need to get this. So this position is like, this is going to be vibrator 1, okay? This is going to be vibrator 1 selected, as in this is vibrator number 1, so vibrator 1 selected, as in this targeting the control of 4AC1, and then thereafter I think we've even done this one. So vibrator number 1 on, so 4AC1, this 4AC1 as a comment, we're saying this is going to be vibrator number 1 on. Okay. Come on, Control Z. I need this. Okay, so this coil power contactor coil is for vibrator number 1 on, which is this part. Okay. Then thereafter we need 4AD1. We've already created the coil. Okay. And then we can just simply align the two coils. So alignment bottom. Okay. So we can control, or rather we can basically just link the neutral end. And then on this opposite end we have the, first off we have the other end of the earth leakage, the double pole configuration. Okay, so this other end goes straight to the end of the coil 481. Okay, so which is this one here, 481. The other end goes to one end of the double pole or 482. So that's what we get. And then thereafter we're saying we also need the two overloads. Okay, so the two normally open contacts associated with 4AE3 and 4AE4, right? So 4AE3, which is this one here, and 4AE4. So do I have normally open 4AE4? So we're talking about 4AE3 and 4AE4, okay, as thermal overload. So these are going to be like in this position. Okay, so let's do this transformation, rotate left, so that's 483, and then which is normally open, right? So what this just says is we have 483, right? And then within 483 we're going to get from in that position, right after 482, but before 483 we'll take a branch off, and then we're going to pass through 483, and then 483 has got another branch which is supposed to pass through after 483, right? We need 484. Yeah, we can even put them side by side. I don't really think it matters, but after this point we're going to pass through 484. Sorry about this, but these two need to change positions. Okay, then this one comes here. So with this configuration, after 483 we're going to pass through this contact. Okay, and then of course the two branches are connected across from each other, and then after that they join into this branch. So, okay, so basically we might as well say do this. Okay, might as well do this. Then from this point we link up to 481. Okay, we link up to 481, so which is basically this configuration. You could also have a situation whereby these two are just in parallel but taking supply from the point 4A2. I mean, that would work just as well. Oh, So powder switch operated, but the powder switch operated should be running in red, not green. Okay, so we'll run the powder switch operated in red. Let's try that again. Okay. Okay, so powder switch operated, so meaning you can't run the vibrator number 1. Okay, so ideally, like I said, the powder switch operated is supposed to be coming from an actual limit switch in the bin, but we don't have the powder switch. So in this position for the powder switch, we've improvised this push button, emergency push button, 2-pole, to simulate the behavior of the powder switch in the circuit. So we have all of this, which seems okay. And then this is just for vibrator number 1. So we can do the same thing for vibrator number 2.
A few minutes later.
Okay, so now we know that when we're starting out, we need to pick which vibrator we're going to run. So if we choose vibrator number 1, then vibrator number 2 doesn't run. It's one or the other, not both. Okay, so we can even choose vibrator number 2, then in which case we get to run vibrator number 2. And then of course what I'm not seeing is CB5. Okay, I'm not seeing CB5, so maybe we need to go into the power circuit. Okay, this is CB5. What's the default run state when we're just starting? Okay, on simulation, closed on simulation start, so we need a true state, save. Then thereafter we're interested in the vibrator control. Okay, so now we notice that the only thing we need to do is select the choice of vibrator to run. Okay, so if we choose to run vibrator number 1, then what it means is the only thing we need is a permissive signal from the main drive, the one we're calling the vibrator control interlock. Okay, and then of course we notice that in the lubrication pump control circuit, we needed to choose the running state of the vibrator. Okay, so in this case we're just going to run it in the normal state. Okay, and then of course for the main drive, okay, we also choose to run the main drive in the normal position. Okay, we choose to run it in the normal we're going to run the vibrator in the main drive. Okay, the main drive, the crusher main drive motor is going to be run in the normal state. Okay, so that's what we have. So other than this, the only thing we need to do is go to the vibrator control circuit. Okay, or rather the lubrication control circuit, and then press the so we needed to run this in the the normal state. Okay, the normal state. So maybe a good idea to reconfirm the main drive. Okay, so this is okay. And so the only thing we need to do is start the system by pressing the system start. What we're hoping to find is a situation where the lubrication pump runs thereafter the main drive, at which point we're going to get the permissive signal for the vibrators. Okay, so the lubrication pump motor runs, and then after a delay we're going to have the main drive or the crusher main drive running. Okay, so when the crusher main drive runs, at this point we can have a permissive signal to run either vibrator number 1 or vibrator number 2. Okay, so what we can do is we can get into the vibrator control, okay, and see that we've selected to run vibrator number 1. Okay, this is vibrator number 1. So what's going to happen is, if we press the local start, then the vibrator number 1 is supposed to run. So that can be seen from the power circuit. You notice that vibrator number 1 is running. Okay, and then alternatively you could choose to stop vibrator number 1, then choose to run vibrator number 2. Okay, so press start like so. So vibrator number 2 is expected to run. Okay, so this shows that vibrator number 2 is running. Okay, so vibrator number 2 is running, which we can confirm from the power circuit. Okay, so this time vibrator number 1 is not running, but the lubrication pump is running, the crusher main drive is running, and then of course we expect that vibrator number 2 is running. Okay, so this is like vibrator number 2. So vibrator number 2 is running. So this is just about it. And then we can go into vibrator control. Okay, then we can stop the vibrator. Okay, so we can choose now to stop the system. Okay, so we'll press the system stop, and then of course you see the power contactor for the main drive, the crusher main drive, open, but the lubrication pump remains, or rather stays running for a predetermined interval, and then it powers down. Okay, so this is the lubrication pump still running, and then it also stops by way of de-energizing for DC1, and then the loop system just stops. Okay, we come to the end of this session where we've been looking at the use of Automation Studio. Okay, so hopefully this has been helpful, or rather I do hope you found this to be useful.